Hello. This time we will deal with two-way ANOVA. Remember that I have explained one way. Here is the 1 and 2 of way ANOVA. Sometimes I told you the last time 1 and this time 2 is the number of independent, right? The number of independent. Okay. 2 independent. Okay, and then dependent. Okay, at least 2. And also, one other assumption which is very good is in case of ANOVA, different from T statistic, we need at least 3 factors. The meaning groups. Okay, 3 groups. More than three groups. Okay, at least 3 groups. Okay, more than 2 groups. Okay, in this case, we use ANOVA. As you can see here, this is weight rows. This is our target variable. So this is a dependent variable. And here is 2 variables, diet and exercise. Okay, the diet and exercise is 2 different groups, which makes an influence on this. Okay, what is the effect between these 3 variables? That is two-way ANOVA. As I told you in previous class, the ANOVA is abbreviations, meaning analysis of variance. Okay, so we see the difference between groups in terms of variance. Okay, we can sometimes use the variance as the same meaning of mean. The mean in statistics is the just meaning of the average in mathematics. Okay, here diet, exercise, and losses. We have 3 variables, but among them, 2 variables, diet and exercise, is independent and weight loss is dependent. So we see the effect of diet and exercise on loss. Okay. So let's see. Then here we can see that the questions regarding this research. Okay. Okay, we will see the question regarding this message. Oh, sorry. Oh, here show you. Okay. So research question, if you see that, you can easily detect. Okay, what it means. This is written like this. How to lose weight effectively. The diet, here is diet, the word diet. This is one variable. Really works. And what about exercise? Okay. In order to find out, okay, 180 participants were assigned to one of diet. We have 3 kinds of diet. This is what? The 3 groups. The groups, the number of groups, right? So groups. And then one of 3 exercise level. So it is also, okay, the groups, right? And after 2 months, participants were asked how many kilo they had lost. The data partially show above are in what is this called? That SAB data. This is the weight loss, right? So in short term, W loss. we are going to test if the mean for weight loss after 2 months are the same for diet, exercise level, and each combinations of diet with exercise level, right? Thus, that is, we will compare more than 2 means. So, we end up with same kind of ANOVA. Okay, now, okay, why we called the two-way is that we can together, okay, see that the impact once the diet and exercise combine together. Okay, maybe it sounds like more effective, right? The diet is a well-known method of losing weight, right? Also, exercise is the same. Okay, the exercise and diet both are well-known way to use to lose weight, right? So we can easily imagine that each of these individually and combined together. It's very curious survey, right? To see the diet and exercise separately and at the same time, right? Is there any difference between, combined effect and then separate effect, right? Because we have learned that the diet and exercise is very effective way to lose your weight. Anyway, let's see that, okay? This is the way, okay? This is the way, okay? We have very familiar words like diet and exercise, which is related to losing weight, right? And then also, we can easily combine these two and see the impact, the combination impact of these two ways of diet and exercise together. Okay, that's the reasons why called two-way ANOVA, because we want to see, okay, the impact of combinations of the method and the way which makes losing weight. So, the main purpose of this two-way ANOVA method is to see the impact of two methods combined at the same time, or separately see the influence on each of the items to losing weight, independent variable, each of them, and combined together, we see the effect on dependent variable. So, let's see more. Here, below, go to below more. Okay, now, case count and histogram. The histogram, we used to use this histogram, inspect histogram for lose weight, because at glance, and then we can compare by using histogram, okay? Where the data, where data is long, or data has something long, or data is just normal, to see that observed weight loss in kilos of to rest months. Okay, as according to the histogram, we do not have any outliers, right? As there is not any data which is very prominent than others, right? So we have no outliers here, right? So the data looks like very similar. It looks like the normal distribution like a bear, right? Okay, here. So we make it the contingency rate the table diet by exercise, and the exercise and diet, and then impact of you make the contingency table like this. Okay, right, this is good. Okay, of course, balanced design number is 2 for each cell. Here's diet none. We have 3 groups here, and vegetarian including. Okay, and then we have also the exercise time here, and then this is total time here. Okay, this is right. Okay, 60, 60, right, this one. This table is called as contingency table, okay, which is used as cross tabulation analysis. So this is showing that, okay, relation between, right? Relations between, okay. Okay, so this is also see that okay, the weight loss observed weight loss in kilo, the unit is kilo of last 2 months, right? This is the way of exercise, right? And then the kilos lost by this parameters is this one, this one, this one, like that. Okay, this is the 3 types of diet, and then this is what? This is the 3 types of exercise, right? And then you can see that it's combined together. This one, this one. Okay, you can see it. Right? This for your easy understanding. This picture is very important, right? Okay. This is the diet assigned to the participant. Okay, diet. The diet. Okay. And then also we have 3 types of exercise. Then, okay. Then we can easily detect whether this one do not make any influence on what? Losing weight. Okay. Or do they make any combination effect together? Okay, like that. Okay, like this, okay. So we can see easily, right? The main effect diet, this is main effect diet, and then main effect exercise, right? This is the main effect exercise, right there. Okay, right, this is the contingency table, which makes us easily understandings of these data right there. Okay, I believe you might understand this easily, right? Okay, let's see the next then. Okay, so this is just for the intermediate paste to makes your understanding easy regarding because we believe that you are not so accustomed to this kind of table, right? Okay, just skip it. Okay, just skip it. Okay, the assumptions, independent value observations, okay, right. This is a revenge test. Okay, then let's go the 2-way. Okay, analysis. Once you go, we have the pull down menu below and go to general linear model. You have to use the general linear model. Okay, then not compare means the general linear model. Once you go to the 1-way ANOVA, you choose compare means, but in case of 2-way ANOVA, you have to select general linear model. Okay, then here is univariate here, and then you can see that one dependent variable, right? So one dependent variable is what? Weight loss, right? Weight loss. Okay. We choose here, right? Okay, univariate. And then whenever we analyze just one dependent variable, okay, regardless how many independent variable, diet and extra, we have 2F, okay? Okay, right there. The dependent variable is our target variable, right? We want to see the weight loss, okay, relation between diet and exercise. So diet and exercise is what? There is a factor, there is a variable, there is an independent variable which is fixed, okay? Because diet and exercise is the fixed, meaning that, then Pratt and Foster Hawk, right? We see it. That's, okay. We select among ID, W loss, okay, and the diet and the exercise we have. So we have a diet and exercise. These two parameter is what? Fixed factor, and then that is what? Dependent variable. So you have to know how you classify this one and then move this one to corresponding parentheses here. Okay, this parenthesis is dependent variable for, and this parenthesis is fixed factors. Okay. Okay, so we can divide it like this. Okay. And then if you press what? Okay, here is the then plot Foster Hawk and options. You can select each of it, okay? And then you will see that, okay, like this. And then estimate of effect size, and then homogeneity test. Homogeneity test is Levin test, right? And we display with the estimate of effect size, right? Like that. And the significant level is 0.05, only below 5%. Okay. Okay. Confidence level is automatically then 5% deducted, total 95% from 100%, right? Like that. Okay. So we are ready. Okay. Okay. Okay, here we have a horizontal axis and then separate line. Okay, here we have two factors, right? Two factors. Then the diet and exercise. We have to univariated, the profile plot, right? To see that relations. Then here we will add diet and exercise, right? Diet and exercise. And then you will plot visualized profit properties for each combinations of factors. So you have two factors, diet and exercise, right? We will see in a minute that this gives a lot of insight, right? Which is insight to how our factor related to our dependent variable, right? The possible interact while doing so. Understand this one? Okay, now we will show that the diet and the exercise, how that is influence on dependent variable. Okay. So now, the first test, diet and exercise. The another options, the diet and exercise, to see which one is related how much right there. To see that, first whole diet is showing that which one is how much related to which one, and then how much similarity to variables is classified right there. Okay, to see that the similarity of the variables we can see. Okay, so now we will see. Okay, and then we will see the revenge test. The revenge, why? Because revenge test is the test to see between the groups that whether the assumptions that, what assumptions? Homogeneity. The Levin's homogeneity assumption is that everybody has a homogeneity. Then, if we reject this hypothesis, the alternative hypothesis will be what? Different. But revenge insists not different, right? So, if our hypothesis is rejected, revenge is right. What the revenge means? The revenge means what? Both sample, both group is homogeneity. Okay? Homogeneity. Anyway, in this result, okay, your significant, the p-value is over 0.05, meaning that, Levin's hypothesis is not rejected. What is Levin's hypothesis? Levin's hypothesis is that there is that, each group's variance is similar, right? Understand? Each group's variance is similar. We call this kind of similarity as a homogeneity. Okay? Homogeneity. Okay. Like this. Okay, here. This is main impact for diet and exercise. Okay? Diet for lose weight and exercise for lose weight. The main effect means to see each of variable separately to what? Lose weight. Meaning that the independent variables impact on directly to dependent variable. Okay? It's just to see that the independent. They do not see, okay, the main effect do not see what? The combination effect on lose weight. Okay, they separately see that. Okay, now the results show that they will make an impact on that, right? They make an impact on that because they are almost 0 and almost below 0.05. Okay, here is that. Okay, this is p-value is the 0.5. Okay, so in this case, number 3, what is that? The diet and exercise together, the combined. This is separate of each. This is each variable effect to lose weight. This exercise and what? Diet. Look at that. Okay. SIG, the p-value is below almost 0. This is also 0, meaning that each of these variable makes an influence on what? Lose weight, right? But in case of this is, look at that, diet and exercise, okay, multiplied effect is quite high. Quite low. Because why? This is 0.5, meaning that it's almost 45. Meaning that the possibility your hypothesis to be wrong is almost 40%. Meaning that, okay, no interaction effect. Understand? Can you, okay. You can easily detect this. This is the, individual effect of each of your variable, diet in case, and exercise in case. But below that, there is that signal, which means the multiplied. So diet multiplied exercise, meaning that their combined effect on what? Whatever, okay? Then it is what? It is almost 0%. This is p-value, okay? P-probability, meaning that, okay, they will make an inference like that, okay? Understand? That's the test of ANOVA. Okay, that's the test of ANOVA. Okay, in case of this one, we can easily detect whether each of variable make an influence on a dependent variable or both of them combined value on dependent variable. Okay, so this is two ways. The meaning of two is that other than two variable is active and checking whether one of them make an influence on or two of them can make an influence on.